This is video number 4 for sections 3.5 and 11.1, solving absolute value inequalities. Okay, so now we're going to put everything together that we've done. We're mixing in the absolute value bars along with the inequality symbols. How would I solve something like this? And the good news is it's basically the same idea that we used in those absolute value equations. If you can isolate the absolute value, and then if you can think in terms of value, you can solve the problem. Let me show you how this is going to work. In this particular problem, the absolute value bars are already by themselves. That's great. There's no other stuff on the outside, no other junk that I need to get rid of. So I'm able to immediately start thinking in terms of mystery number. I have a complicated mystery number. It's 2x plus 1. So there's my mystery number. I don't know what that mystery number is, but let's think about what I do know. The value part of that mystery number is less than or equal to 7. Now that's a little different than we had before. If it only said that the value part was equal to 7, well, I know there's only two spots you can go where the value part is equal to 7, either negative 7 or positive 7. Another way to say it is because you can only walk 7 steps to the right here or to the left and end up here. The less than, though, says, well, wait a minute, you don't have to actually be exactly 7 steps away from 0. You can be anything less than 7 steps. So like right here, for example, or right here, or right here. Really anywhere in this section, you would have walked less than 7 steps away from 0. Or you could say it, all of these numbers have value parts that are below 7. Now forget it out here. You know, once you get to 8 or 9, those numbers, or negative 8 or negative 9, those numbers have value parts that are too big. But anywhere in here, 1, 2, 3, 4, 5, negative 1, negative 2, all of those value parts are less than 7. I think drawing it is so helpful because now I get to the part where I list my possibilities. Well, that listing is going to look a little bit different here because look at this picture. It's not just 2 dots like we had before. It's a whole section of numbers, right? This green shading, that's where I know my mystery number is located, somewhere in that green shading. Well, notice that this is a between picture. My mystery number is in between negative 7 and positive 7. That's exactly what I need to write over here. My mystery number is between, remember, 2 less thans, 1 on either side, negative 7, the smaller number, and positive 7, the bigger number. And I think I need equals, right? Because we've already said it's okay. You can be right at 7 or negative 7. That would still work because I've got an equals in the problem. This is the listing of the possibilities. Now I know where my mystery number is. It's between those two numbers. Well, this is one of those compound inequalities. This is the one where as long as I do the same thing to all 3 sides, I can solve the problem. So I'll start by subtracting 1 in my effort to get that x by itself. And then it looks like I'll need to divide everybody by 2. And what I'm going to end up with in the end is this statement, which is probably best read as x is between negative 4 and 3, including negative 4 and 3 because of the equals, but x could be any number between negative 4 and 3. What are we saying? We're saying back in that original problem, if you picked any x between negative 4 and 3, you will make a true statement. Just like before, they may ask you to draw a number line picture of your answer. That would be pretty straightforward. Remember, this number line here was just a tool. This is not part of the answer. This number line would actually contain the answer. I would need negative 4, and I would need 3, and I'm shading in all the numbers in between, including the ends. So here would be a number line picture of the solution. And the interval notation, left number negative 4, comma, right number 3, and both in brackets because I'm including the ends. That's solving an absolute value inequality. Definitely tricky. I mean, make no mistake. And I think the tricky part is because you have to do the thinking. You have to use this tool and think about the mystery number. Let me show you one other example here. So take a look at this example. It looks very similar. This time the absolute value bar part of the inequality is not by itself. It's got this 2 out here on the outside, so I'm going to have to divide both sides by 2 as a starting point. You've got to get the vertical bar part by itself before you do anything else. Once you do that, everybody in there is trapped in the vertical bar, so don't touch it. You've got to rid yourself next of the vertical bar. Here's my mystery number. It's x minus 3. And let's see, what do I know about this mystery number? I don't know anything directly about it, but I do know that the value part of the number is more than 2. So if I draw my typical tool here, let's see, if it was exactly 2, then of course I'd go out 2 spaces to the right and I'd go out 2 spaces to the left. But I'm looking for numbers that have a value part bigger than 2. Well, these numbers would work. 3, 4, 5, 6, 7. They all have value parts that are bigger than 2. Where else? How about numbers like -3, -4, -5, -6? The value part of those numbers would be bigger than 2. Or you can just think in terms of counting spaces or taking steps. I just want to walk more than 2 steps. Well, if I walk more than 2 steps to the right, I end up over here. If I walk more than 2 steps to the left, I end up over here. Now it's time for me to write down my possibilities. Now, pay attention to this. In the last problem, after I used my tool, I was sitting and looking at a between picture. That is not the case this time. This is not a between picture. In fact, these are 2 separate sections. My mystery number, I cannot write a between statement. My mystery number could be in this green section. That green section is all numbers that are below -2. Or my mystery number could be in this green section. That would be all numbers that are bigger than +2. I use the tool in order to help me write out the possibilities. Once you've made it to this step, you're home free. You just have to isolate the x. That's going to be very easy. Just add 3 to both sides in both of these things. And it looks like I'm getting a final answer of x is less than 1 or x is bigger than 5. That's the answer to the problem. And you may be looking at that saying, well, I don't want to write it like that. I want to write it all nice and short like we did in the last problem. Well, we can't because this wasn't a between situation. This is not a between answer. This is 2 separate groupings of numbers. X is less than 1 or x is bigger than 5. If I was to draw a number line picture of the answer, I would have to go to 1 and I would have to go to 5. And then I'm supposed to color in numbers that are lower than 1. Well, that would be all of these numbers over here. And numbers that are bigger than 5, notice that I'm using open circles because I don't have equal signs here. I don't have equal signs here or here because I didn't have one in the original problem, right? 2 and -2 back on my tool were not included. I had to be only more than 2 steps away. So I'm using open circles. Here would be shading in for numbers that are bigger than 5. This is not a between picture. This is not a between answer, so I can't write it that way. The third way is maybe the most challenging here. For the interval notation, I'm going to have to write this in 2 pieces because I have 2 pieces to my picture. So first piece runs from -infinity down to 1. No brackets anywhere in this problem because I don't have any closed circles. Second section runs from +5 down to +infinity. And then when you have a situation like this where you're using interval notation with two separate pieces, there's a math symbol that goes in between. It looks like the letter U. It's called a union symbol, but it is a special symbol. It's not actually the letter U. It just kind of looks like that. In my math lab, when you get to these problems, look in the toolbar at the bottom and you will see a union symbol that you can type in for these particular problems. Solving absolute value inequalities, a little bit tricky, but follow the steps. Here's the good news. There really are only two types of these problems, and I've worked one of each for you. The ones that start with a less than are going to be between problems and work like this first example. The ones that start with a greater than in the problem are going to be two section problems and work like this second example. So those are really the only two things that can happen to you, and in that sense it makes the learning of it a little bit nicer. Obviously you'll want to practice this so that you can become skilled at it.